Hey guys, welcome to my channel. So as in we are going to the series of semiconductor physics or electronic devices and circuits. So we are on the topic of charge neutrality. So in the last class we have discussed majorly on the intrinsic and the extrinsic n-type. So continuing to this, let's start with the p-type. I hope this concept is clear. You are in phase. If you guys haven't gone through that video, please watch that and come back here. So if we know that in p-type, the donor atoms will be 0. The acceptor atoms will be greater than 0. So from the equation 1 charge neutrality, here we can directly write that P which will be equal to Na plus N. So this is the neutrality condition. So we can directly use the mass action law that Np which is equal to Ni square. So first thing is we need to find the majority charge carrier. So from that the majority charge carrier is the P. So we have to substitute the equation for N with the P. So N which is equal to Ni square divided by P. So we can substitute that in this one. So if we substitute this here, then we will get P which is equal to Na plus Ni square divided by P. Then if we make this into a quadratic equation, then we will get P square minus NaP minus Ni square which is equal to 0. So if we substitute that quadratic equation formula, then we will get P which is equal to Na divided by 2 plus or minus root Na divided by 2 the whole square plus Ni square. This is the exact calculation. So if we know the majority charge carrier, then we can directly substitute the back in this formula and we will be getting the minority charge carrier. So first thing we will calculate this and second one we will calculate this. So this gives the exact formula. So another one shortcut is there, right? So if Na is much greater than Ni, then we can directly ignore the second term and P will be approximately equal to Na. Then we can directly substitute that in minority charge carrier also, Ni square which is equal to Na. So this is approximate calculation. So this is prox calculation. Last one is the exact calculation. So you may think that this is the exact thing, but in the real world scenario, there is the fourth term called compensated semiconductor. Compensated semiconductor, which may be n-type majority or p-type majority. So let's take the case where n-type is majority. So this is the case where both is not equal to 0. Like there will be acceptor atom, there will be donor atom, both will be there. Like Na will also be greater than not equal to 0 and Nd will also be not equal to 0. So in this case, but another one condition is that Nd will be much greater than Na. So that's why we are taken the compensated semiconductor to be n-type. So this is a semiconductor where both impurities are doped and the majority charge carrier will be Nd, but Na is also significantly present there. So then the charge neutrality equation will be what? There will be nothing will be eliminated. So everything will be as it is. So this is the charge neutrality equation. So let's take P, which is the minority charge carrier. So let's find out this. So let's substitute this in the first equation. Then let's see what we are deriving, what we able to get it. So Nd plus Ni square divided by N, which will be equal to Na plus N. Okay. So then if we make this into quadratic equation, then N square minus of Nd Na with sub N with Ni square, which will be equal to 0. So if we again use the quadratic equation formula, then the majority charge carrier will be the same thing, but there is a difference of these two things, plus the root of plus or minus root of Nd minus Na divided by 2 the whole square. This is whole square plus Ni square. So this is the term here. So if we here also same, now we can what we can do, if we have to find the minority charge carrier, then Ni square divided by N. So this N is here. So this is exact one. So here also we can make the approximation that if Nd minus Na, which is much greater than Ni, then we can ignore this term. So if we ignore this term, then N will be approximately equal to Nd minus Na. Then this one we can apply into minority charge carrier finding formula. So Ni square, which will be divided by Nd minus Na. This is approximate. So similar to that, exactly, there is a fifth type called compensated semiconductor for p-type. So compensated semiconductor for P-type. Okay, now what will happen? The same thing. Na will be much greater than Nd, but both are not equal to 0. So in this case, so if we apply this in a charge neutrality equation, then we will able to get the final form. I am directly writing the Nd equation, so take this as a homework and write. Just the charge will only reverse. So Na minus Nd divided by 2 plus root of Na minus Nd divided by 2 the whole square plus Ni square. So this is the exact one. Then we can substitute this into find the minority charge carrier. That will be Ni square divided by this P is here. Okay. So then if the condition of approximation that Na minus Nd is much greater than Ni square, Ni, then the majority charge carrier will be approximately equal to Na minus Nd. So then we can directly apply this in the N, that will be equal to Ni square divided by Na minus Nd. So this is approximate calculation. So we are seeing both the exact and approximate calculation. Okay, I hope this is understood for you. So in the next class, let me have a small problem of discussion over this so that you guys able to understand it. So then we will be again going to uniform and non-uniform doping. Okay, so this is how if we have to substitute these things, how the theory will work, then we have to substitute the exact values in the problems that we are giving. So let's consider a problem. So if they are giving a semiconductor with Na, I am directly writing the values for you guys to understand. So that will be 5 into 10 power 14 centimeter per minus 3. This is one value. Then Nd, which is equal to 5 into 10 power 18 centimeter minus cube. So here you can clearly see that Nd is much greater than Na. So this is a compensated P-type, sorry, N-type, compensated P-type. So majority charge carrier can be written. This is exact calculation, right? So Nd minus Na divided by 2. So plus or minus root Nd minus Na divided by 2 the whole square plus Ni square. Here Ni, which is given as 10 power 10. So which is always 10 power 10. So which is 10 power 10. So if we substitute here, we will be getting the formula, we will be getting the value. Plus minus 2 value is there. So mostly we will ignore this negative value. We will consider only plus value here for all the one. So if we find this, then the minority charge carrier can also be easily found. That is Ni square divided by N. So this is the exact calculation that we can follow. So please follow, please try to make you substitute all this in this and try to follow. Try to give the answer. Please post the answer in the comment section. This is the first method. So in the second method, we can directly take a approximation that N will be directly equal to Nd minus Na. So in this case, just subtract both things and some answer will come. Then please substitute that answer in the Ni square divided by N. So try to answer both the part, like comment the answer as 1, which is equal to what the answer getting here, like both P and N, and comment the 2 and post all the answer like what is N, what is P. Let's see how the margin of error is happening in both the things, like exact and approximation. So let's see how the things is coming. So I'm giving this to you. So you guys just post the answers in the comment section so that everyone will be able to view it and we can cross check it. From next classes we can see how the margin of error is coming here, like that way we can make an analysis over here. So I think the charge neutrality equation is done. So from next class we will be going through uniform and non-uniform doping over the P-type and N-type. So stay tuned for the upcoming lectures. Like, share and subscribe the channel. I hope this is giving you a lot of information. I hope we can easily get into any kind of dream jobs that you guys are expecting and waiting for you guys in your college final years or even your off campus. So stay tuned for all those things. I'm also going to start a placement series, like I will be giving important questions, like what are the questions asked in the core placement. Just I will make a shorts on that and 1 minute shorts. You guys also able to view that one. Stay tuned for next upcoming lectures. Thank you guys.